So this video is about basic examples of integration by parts, and we also want to compare integration by parts to U substitution or substitution. Now, again, what formula am I using for integration by parts? The formula for integration by parts is integral of u dv. So if you have basically a function u, or the other way to express this is basically u v prime dx. If you have that sort of integral set up, and you cannot do it with the methods that you know, it might be that you can use the integration by parts, and that is you basically use the u times v, and then you subtract by v u prime dx. That's the other way of expressing the formula that we discussed before. And so now, always the story is, how do I know which one's integration by parts, which one is a U substitution, and what do I choose for U, what do I choose for V? Part of it is that there are known functions, and we talk about those as we go through the videos. But the other part is that just by some intuition, and so you gather some memory of this, and then you gather some intuition, and then you choose your U and V. Here, let me box a kind of the space is limited, so I'm going to box the formula. And the first example I want to do is x sine of x dx. The second example I want to do is x sine of x squared dx. Well, going back to my knowledge of substitution, I remember that when I have a function of x squared and x is multiplied by that function, it's sort of a chain rule happening in there, and so substitution is a way to go. Now, in here though, I don't have that. So basically, if I want to mark something for substitution, that would be it. And if I want to choose integration by part, this one is an integration by parts. And so now, x sine of x dx, I don't have any rules to use except for integration by parts. How do I choose u and v? So v u prime. So basically, how do I choose u and v prime in here? So v and u prime, the product of that is an easy integration. One way is that, and I did that in the first video, is to choose u to be x. Then if I take the derivative of x, I will end up with 1, which is multiplied by anything. It will be just antiderivative of that thing. Basically, this side will be simplified, not a product anymore. And also, if I choose sine of x, so here's the plan. I'm choosing that to be u, and this one to be v prime, and then antiderivative of sine of x is easy to do because we know that already. And so now let's write it down. See, I have a pattern, and I tell you later why this pattern is important. So I'm choosing u to be x and dv to be sine of x dx. Basically, v prime is sine of x, so sine of x dx. And then I do du to be derivative of u times dx, which is 1 times dx. And then antiderivative of this whole thing, which gives me v, is antiderivative of sine of x dx, and that would be negative cosine of x. You don't need that plus c and stuff. Don't worry about it. So now that I have this, The formula tells me multiply these two, the diagonal, the main diagonal, and then take the antiderivative of a product of these two. So it would be x, negative x times cosine of x minus v, which is negative, minus integral of v, and du, which is dx. And so what I end up with is negative x cosine of x. That one has an integral, so antiderivative of negative cosine of x would be negative sine of x. That's plus sine of x plus c. And so that's how we do the integration part by parts for x sine of x. Now, how about x sine of x squared? If you remember, we used to do u equal to, remember, u substitution, we used u and u also. And for integration by parts, we use u and v. And for u substitution, we use u. So let's u to be the inside function, because I can clearly see a chain rule in here. And then what is du? Du is derivative of x squared, which is 2x times the differential. And then what I do is, I see these two is x dx, so I solve for x dx, and I get 1/2 of du. And then I replace that one by, so what I get is sine of u squared, u. The whole point was that we get rid of the square inside of a sine. So sine of u du times 1/2. And solving that gives me negative 1/2. Antiderivative of sine of u is negative cosine of u, and plus c. Plug back in what u is, because you're taking antiderivative in terms of x. And that is done.